You're listening to an article by Eminent, an expert in aerospace engineering and technical consultation. See us at eminent-design.com. Aircraft equipment often encounters humidity, whether from environmental exposure during ground operations, condensation at high altitudes, or moisture-prone areas within the aircraft itself. RTCA DO 160 Section 6. Humidity testing evaluates equipment's resistance to prolonged moisture exposure to ensure it remains functional without deterioration or electrical failure. This section is crucial for verifying that airborne systems are built to withstand humid environments without impacting performance. Below, we'll explore Section 6 testing, including its categories, typical failures, mitigation techniques, and its role in airworthiness and flight safety. Why RTCA DO 160 Section 6 is vital for flight safety and airworthiness. Humidity exposure can lead to corrosion, condensation, insulation breakdown, and electrical malfunctions, all of which compromise equipment safety. Section 6 ensures that airborne systems are resistant to these risks, validating that they can operate reliably in moisture-laden conditions. Compliance with humidity testing standards enhances airworthiness by reducing the risk of moisture-related failures and ensuring equipment longevity in all environments. Key categories of humidity testing in DO 160. Section 6, DO 160 Section 6, classifies humidity testing into categories that simulate different levels of moisture exposure. Based on FAA standards and customer requirements, the appropriate testing category is selected depending on the equipment's installation location and expected exposure to humidity. Category A. This category simulates high humidity exposure, with testing performed at up to 95% relative humidity. Failures often include corrosion of metal parts and degradation of electrical contacts. Mitigation. Using corrosion-resistant materials, protective coatings and sealed connectors can prevent damage in high humidity environments. Category B. For equipment that may face temperature cycling alongside high humidity, Category B tests replicate real-world fluctuations in temperature and humidity, which can cause condensation buildup. Failures often involve water ingress into electronic systems. Mitigation. Conformal coatings on PCBs, moisture-proof seals, and ventilation channels can help reduce condensation buildup and water ingress. Category C. This accelerated humidity test exposes equipment to shorter durations of high humidity, focusing on durability over brief but intense exposure periods. Failures may include insulation breakdown or material swelling. Mitigation. Selecting moisture-resistant insulation materials and reinforcing connections helps prevent breakdowns and maintain structural integrity. Typical failures in humidity testing and effective mitigations. Humidity testing frequently identifies specific issues that can impact equipment functionality, especially in electronics and systems exposed to varying temperatures. Corrosion and rust. High humidity can cause corrosion on metal components, weakening structural integrity and connections. Mitigation. Using stainless steel or other corrosion-resistant materials and applying protective coatings can extend equipment life. Electrical short circuits. Water ingress into electronic systems can cause short circuits, leading to performance degradation or failure. Mitigation. Sealed enclosures and conformal coatings on circuit boards keep moisture out of critical electronic components. Insulation degradation. Exposure to moisture can break down insulation on wiring and other components, creating risks for shorts or leaks. Mitigation. Using high-quality, moisture-resistant insulation materials helps maintain durability and electrical stability. Swelling of non-metallic parts. Certain materials, especially plastics, can swell in response to moisture, misaligning components, or reducing effectiveness. Mitigation. Selecting materials resistant to moisture absorption or using protective coatings on vulnerable parts can prevent swelling. Rationale. Behind humidity testing. Humidity testing under DO 160. Section 6 verifies that equipment can withstand moist conditions that might otherwise lead to corrosion, short circuits, and component misalignment. Testing categories simulate real-life environmental exposure, confirming that equipment maintains its functionality and integrity even in high humidity or condensation-prone areas. FAA guidelines and customer specifications determine the appropriate category, ensuring equipment is suited to its operational environment and enhancing safety. Consulting for RTCA DO 160 Section 6 testing. How Eminent can support your certification needs. At Eminent, we offer specialized consulting for DO 160 Section 6 certification, providing guidance on design strategies that protect against humidity-related risks. If you encounter compliance challenges during testing, our experts can work with you to implement effective solutions and ensure your equipment meets humidity standards confidently and successfully. Thank you for listening. Please check out our articles on other DO 160 sections.